Right now, beneath your feet, there's a world, an invisible world, a civilization of billions, ants, those tiny creatures in your garden, that line on your kitchen counter, that speck you stepped on the sidewalk. But what if one night, while you slept, they grew to your size, human-sized ants? When you woke up in the morning, you'd find the world completely changed. And the truly terrifying part, when they reach your size, you'd no longer be the dominant species. Imagine an ant your size, 5 feet 7 inches tall, 150 pounds, but with an ant's strength. An ant can carry 50 times its body weight. How powerful would a human-sized ant be? A creature with armored exoskeleton, 6 legs, powerful mandibles, and remember, they're never alone, never. They move in millions. Tonight, we'll answer this question, and some answers might make it hard to sleep. But first, let's understand. How does an ant become giant? A normal ant is about 5 millimeters long. Some species are larger. Queen ants can be 15 to 20 millimeters, but most are smaller than your fingernail. Now imagine, overnight they grow 1,000 times, from 5 millimeters to 5 meters. Bus-sized ants. But size isn't everything. The real issue is physics. Scientists call it the square cube law. Galileo Galilei discovered this in 1638. It states when an object's size increases, its volume, and therefore weight, increases by the cube of the scaling factor, but its structural strength increases only by the square. Simply put, if you double an ant's size, its weight increases 8-fold, but leg strength only increases 4-fold. This is why giant insects should theoretically collapse. They can't support their own weight. But tonight, we're setting physics aside. We're imagining that somehow ants solved this problem. Maybe stronger skeletal structure, maybe more robust chitin armor, and thus giant ants can stand. Now, the real question, what happens in this world? Last night when you went to bed, everything was normal. In your house, in your bed, peacefully sleeping. Morning, you wake to a sound. A sound from outside your window. Rhythmic, metallic, like someone tapping glass with an iron rod. You open your eyes, the room is dark. You've woken up before your 6 a.m. alarm. The sound continues. You get out of bed, open the window curtain slightly, and what you see defies imagination. In your yard, in front of your house, a giant ant. But giant doesn't do it justice. This is vehicle-sized. Black, shiny exoskeleton, 6 legs, each as thick as a tree trunk, head the size of your chest, antennae in constant motion, and that sound, the ant's feet, with each step, chitin feet striking the ground. For a moment, you freeze. Your brain tries to accept this scene, but can't. Are you dreaming? You pinch yourself. It hurts, real. The ant is walking in your yard, moving over the grass, no, crushing it. Each step leaves a crater, then it stops. Antennae turn toward your house, as if sensing you. Its head turns toward the window, and in that moment, you lock eyes, human and ant, glass between you. The ant's eyes, compound eyes, black hemispheres made of thousands of tiny lenses. Can it see you? Does it understand you? Then suddenly it turns and walks away. Click, click, click. Walks down the street and turns the corner. Gone. Your heart is pounding. You forgot to breathe. You take a deep breath. You reach for your phone. Open the news. Every channel showing the same thing. Stay inside your homes. Giant insects in the city. Live broadcasts. Giant ants walking through Times Square in New York. In Tokyo, Shibuya Crossing filled with ants. In London, dozens of giant ants in front of Parliament. Worldwide, everywhere, simultaneously, ants have become giant. Now let's get to know these creatures more closely. A normal ant is an engineering marvel, but a human-sized ant, something else entirely. First, the exoskeleton. Ants have their skeleton outside their body, a hard armor made of chitin. This armor protects the body, supports organs. In a human-sized ant, this chitin armor could be as thick as tank armor, bulletproof, maybe some weak points like joints, but generally impenetrable. 6 legs. Each leg consists of 3 main joints, each joint controlled by powerful muscles. A normal ant can carry 50 times its body weight. A human-sized ant could theoretically carry 3 to 4 tons. A car, easily. Speed is also impressive. Normal ants can move at 300 times their body length per second. Human-sized, that's approximately 30 to 40 miles per hour. Car speed running, mandibles, jaws. In normal ants, these jaws can cut leaves, crack seeds, dismember enemies. Human-sized, they can cut through tree trunks, split cars in half. And the eyes, compound eyes, made of thousands of tiny lenses. Each lens captures images from a different angle. The brain combines them. Mosaic vision, 360-degree field of view. Motion detection is incredible, but they can't see detail. Colors limited, more shape, movement, light shadow, and antennae, the most important sensory organs. Smell, taste, touch, even detecting sound vibrations. Human-sized ants, using these antennae, could detect pheromones from miles away. A food source, a threat, a companion. Can they fly? Some species fly, especially queens and males during mating season. But wings are small. Scaled to human size, wings might not be sufficient to lift the body. Maybe some species can fly, the lighter ones. But most walk, and walking is enough. But their real power isn't in being alone, it's in colony life. An ant colony is like a superorganism. Thousands, millions of individuals working for a single purpose: the queen's survival and the colony's growth. Human-sized ants maintain this social structure, maybe even strengthen it. A colony has a strict hierarchy. Queen, the colony's heart, the egg layer. All ants are her offspring. A human-sized queen could be 30 to 50 feet long, massive. She might have wings but never flies. Hidden deep in the nest, workers, 99% of the colony, all female, all sterile. Their tasks: gather food, feed young, build nest, serve the queen. Human-sized workers are the ants you see. Soldiers, the colony's defense. Larger mandibles, stronger bodies. In some species, Soldiers are twice the size of workers, human-sized. That means 10 to 15 foot long soldiers. Males, only one purpose, mate with the queen. After mating, they die, no contribution to the colony. In some species, males have wings. Communication is entirely chemical. Pheromones. When an ant finds food, it returns to the nest, leaving pheromone trails. Other ants follow this pheromone trail, thus an ant trail forms. Alarm pheromones. When an ant is attacked, it releases alarm pheromones. All nearby ants attack. Human-sized ants, this pheromone system is much more powerful. Pheromone clouds can spread for miles. Thousands of ants can gather at one point in seconds. In collective decision-making, ants make decisions democratically. For example, when choosing a new nest site, scout ants find potential locations. They return and vote to others with pheromones. The most voted location becomes the new nest. Human-sized ants, using this collective intelligence, can plan cities, organize coordinated attacks, develop strategies, and remember, no pity, mercy, fear, only the colony. Individuals are insignificant. A dead ant is 0.0001% of the colony. No loss. First day is chaos, cities in panic, people hiding in homes, streets empty. But ants don't care. For them, the world hasn't changed, just proportions. An ant was looking for a breadcrumb. Now it's looking for something car-sized. A dumpster? Perfect. Giant ants tipping over dumpsters, carrying food inside, in orderly lines, taking it back to their nests. A park occupied by ants, huge holes in the ground, nest entrances, mounds of earth, vehicle-sized. Police try to intervene, but what can they do? Weapons ineffective. Bullets hit chitin armor, ricochet back. A police car approaches. Ants turn, antennae moving, pheromone signal. Suddenly, dozens of ants running toward police. Footsteps. Police retreat to the car. Vehicle speeds away at full throttle. Ants don't chase, just watch, then turn back to their work. Military gets involved. Tanks, helicopters, soldiers. An ant colony near a military base. Base commander orders evacuation of ants. Fire opened. Heavy machine guns, tank shells. Some ants hit, especially when shot at joint points. Legs come off. But for every ant hit, 10 more come. And some species have special abilities. Fire ants, painful venom. Human-sized, this venom is lethal. One bite, heart attack in minutes. Bullet ants, powerful mandibles, human-sized. One bite can cut a human in half. Army ants, the most dangerous, nomadic ants, never build nests, constantly moving in millions, eating everything in their path. Human-sized army ants could destroy a city. End of first day, humanity retreating. Some parts of cities abandoned to ants. Ant nests are engineering marvels. Underground, complex tunnel systems. Chambers, corridors, storage, garbage dumps, cemeteries. In a normal ant nest, chambers are millimeters. In human-sized ants, chambers are house-sized. An ant nest goes meters deep. In some species, 20 to 25 feet. In human-sized ants, nests could go miles deep. Giant cities carved into the Earth's crust. Ventilation systems exist. Ants dig special tunnels to ensure airflow. Hot air rises, cold air descends. Natural air conditioning, humidity control. In some chambers, ants maintain soil moisture. They grow fungi. Yes, some ant species are farmers. Leafcutter ants, leaf cutters. Cut leaves, carry to nest. But don't eat leaves, grow fungus on leaves, eat the fungus. Human-sized leafcutter ants can completely strip trees, destroy a forest in days, and their nests, underground fungus gardens stretching for miles. The largest agricultural facilities humanity has seen. The queen chamber, deepest in the nest. The safest place, soldiers constantly stand guard. A human-sized queen, a massive creature, 50 feet long, swollen abdomen, only lays eggs, tens of thousands of eggs daily. Workers constantly feed, clean the queen. The queen releases a pheromone, queen pheromone. This maintains colony morale. If the queen is healthy, the colony is healthy. Eggs in a special chamber, larva chambers, pupa chambers, separate sections for each age group, garbage dump, away from the nest. Ants are very clean. Dead ants, waste, all carried to a special chamber, prevents infection spread. In some species, cemeteries exist. Dead ants neatly stacked. Why? We don't know. Maybe just order. Human-sized ant nests, more complex than modern cities. Self-sustaining, self-directing, living organisms. Giant ants affect every aspect of the ecosystem. First, plant life. Ants eat a lot of plants. Seeds, fruits, leaves. Human-sized ants consume tons of plant material daily. Forests rapidly shrink, trees stripped, grasses disappear. But something interesting happens. Some plants cooperate with ants. Acacia trees naturally have symbiotic relationships with ants. The tree provides ants with food and shelter. Ants protect the tree from herbivores. Human-sized ants might protect some trees, especially trees that emit scents similar to queen pheromones. Soil fundamentally changes. Ants dig incredible amounts of earth. Underground tunnels aerate the soil. Normal ants are good for the ecosystem. Enrich soil, aerate it, spread seeds. Giant ants amplify this effect, but excessive digging can cause soil erosion. Animals, most flee. Mammals, birds, reptiles, all stay away from ants, but some animals feed on ants. Ant-eaters, pangolins, with human-sized ants. What do these do? Ant-eaters can no longer eat their prey, maybe starve, maybe find other food. Birds eat some ant species, but no longer. Maybe some large predatory birds, eagles, can hunt injured ants. Who becomes the predator, humans or ants? Humans can kill giant ants with firearms, explosives, but difficult, and ants have numbers. Ants can kill humans, powerful mandibles, venom, and numerical superiority. A balance forms, humans in some areas, ants in others. Months pass, humanity adapts, cities restructuring. In areas without ant infestation, Life continues, but always alert at building entrances, ant-proof barriers, special chemicals, scents ants dislike, peppermint oil, citrus peels, vinegar, natural ant repellents, also effective for human-sized ants. Don't kill them, but keep them away. City walls being built, high, solid walls. Ants can't climb, most species can't. Smooth, slippery surfaces stop ants. Some cities completely sealed. Life under domes. Controlled environment. Food production changes. Can't farm in the open. Ants take everything. Vertical farming. In buildings, farming between floors. LED lights. Hydroponic systems. Meat production. Lab-grown. Raising animals risky. Ants can raid herds. Some communities learning to live with ants. Showing respect. Trying to learn pheromone language. Scientists studying ant behavior, decoding pheromone formulas, looking for communication methods. And indeed, some progress. Certain pheromones being produced. Go away pheromones. This is dangerous pheromones. Directing ants is possible. Not full control, but influence. Some people trading with ants, giving ants sugar, protein. In return, ants provide some services. Pest cleaning, structure construction, symbiosis, just like acacia trees, new professions emerging. Ant mediators, pheromone engineers, nest mappers, children learning ant behavior in school, which species are dangerous, which harmless, how to avoid, how to show respect, culture changing, ants in artworks, movies, songs, stories, sometimes horror themed, sometimes admiration themed, some people deifying ants, new religions, colony faith, inspired by unity, cooperation, self-sacrifice. Some others vowing to exterminate ants. War groups, ant hunters, humanity dividing, but living, surviving. Not all ants are the same. Over 12,000 species exist. Each species has unique behaviors. Leafcutter ants cut leaves from trees, carry to nest, grow fungus, eat fungus. Human-sized, carrying giant leaf pieces, can strip a tree in hours. Underground fungus farms, football field-sized, among the most intelligent ants, complex societies, highly developed division of labor. Army ants, nomadic, never build nests, constantly moving, form columns in millions, eat everything in their path. At night, make a living nest, clinging to each other, protecting the queen in the center. Human-sized army ants, among the most dangerous species. An attack column can pass through a city, leave it empty, blind, can't see, but smell sense perfect. Following pheromone trails, perfect coordination. Fire ants, painful bites, alkaloid venom. In humans, pain, itching, sometimes allergic shock. Human-sized, venom lethal. A few bites can kill even an elephant. Aggressive, attack en masse when threatened. Can make rafts on water, clinging to each other. During floods, colony stays above water. Human-sized fire ants can cross waters, rivers, lakes, forming rafts. Bullet ants, world's most painful sting, 4.0 plus on Schmidt Pain Index, highest. Named because the sting feels like a gunshot wound. Human-sized, one bite, unbearable pain, shock, maybe death, but rare. live in Amazon rainforests, few in number. Honeypot ants have special workers called repletes, abdomens giant filled with honey, living storage during drought. Other ants feed from them. Human-sized, these repletes maybe have 15 to 20 foot diameter abdomens, tons of honey. Weaver. Ants build nests by joining leaves. Larvae produce silk. Ants hold larvae, sewing leaves together. Human-sized, giant nest structures in treetops. Silk threads, cable thickness, very aggressive, defend their territory. If humans approach, mass attack. Each species presents different challenges. Humanity developing methods to deal with each species. Are ants intelligent? Individually, no. An ant's brain has 250,000 neurons. Human brain, 86 billion neurons. But collectively, different story. Ant colonies display collective intelligence. Simple individuals solve complex problems. Bridge building. Ants make living bridges to cross gaps, clinging to each other, forming a chain. Other ants cross over, human-sized giant living bridges, cross rivers, chasms. Raft making. Fire ants make rafts during floods. Thousands of ants unite, forming a waterproof layer, human-sized rafts that could cross oceans. Maze solving. Ants can find the shortest path using pheromone trails. Initially, walk randomly. When food found, leave pheromones. Shorter path, stronger pheromone. Over time, shortest path becomes clear. Human-sized ants, excellent at city navigation. No need for maps. Agriculture. Leafcutter ants grow fungus, feed fungus, maintain it, discard diseased parts. Not primitive agriculture. Complex agriculture, monoculture, single fungus species, grown for generations, human-sized industrial-scale agriculture. War strategies. Ant colonies fight for territory, for resources. They use tactics, siege, ambush, retreat, human-sized military strategies, coordinated attacks, defense lines, and memory. Ants remember locations, food sources, dangerous areas, use visual cues, sun position, ground markers. Some species can count steps. After thousands of steps, know nest distance. Human-sized, these abilities grow, maybe can't communicate with words, but can understand, can cooperate, and remember. They learn, gain experience. Young ants learn from older ones. Culture, maybe. Simple culture. Years passing. Humanity and giant ants found a balance. Some areas human territory, some ant territory. Borders exist. Agreements. Silent agreements, but agreements. Humans understand ant behavior very well now. Which pheromone means what? Which behavior signifies what? Ant watchers exist. Experts monitor colonies, predict movements. Today, queen colony moving east, looking for new nest. Evacuate 3rd Street. And indeed, ants come, pass, go, without harming anyone. Some cities partnering with ants, building sugar factories, giving ants sugar. In return, ants provide pest control, eating rats, mice, other unwanted creatures. In construction projects, ants used. Heavy load carrying, digging, thanks to their strength, much more efficient than humans. In agricultural areas, some ant species cause damage, but some help. Need to keep leaf cutters away from farms. But bullet ants eat pest insects, new generations growing up with ants. For them, this is normal. When grandparents say ants were small, they can't even imagine. Children visit ant nests on school trips, from safe distance, observing, learning. Look, children, here are worker ants carrying food. See the order? And ants are changing too, evolving, maybe more tolerant species toward humans emerging, natural selection, colonies cooperating with humans survive better, maybe communication developing, pheromones more complex, carrying more information, maybe, just maybe, real language developing. Symbolic communication, distant future, but who knows? 100 years later, human-ant hybrid cities. Underground belongs to ants, above ground to humans, but mutual benefit. Symbiosis. Humans benefit from ants' digging abilities. Metro systems, tunnels. Ants benefit from human technology. Heating systems, protected areas, and maybe, one day, real communication, real understanding. Two intelligent species living together. But all this is just imagination. Right now, ants are small. Millions exist. But beneath your feet, a world you don't see. What does thinking about this scenario teach us? First, scale. Size changes everything. A tiny creature, when enlarged, becomes something completely different. Second, social structure. Ants aren't powerful because individuals are strong. Powerful because they work together. Humanity celebrates individualism, but collective power cannot be ignored. Maybe there are things to learn from ants. Cooperation, self-sacrifice, common purpose. Third, adaptation. Ants have existed for 100 million years. Before dinosaurs, they went extinct. Ants remained. Why? Because flexible, because they can adapt, because they have survival strategies. Humanity is currently the planet's dominant species, but this isn't forever. If we can't adapt, another species takes our place, maybe ants, maybe something else. Fourth, respect for small things. An ant is small, seems insignificant, can be crushed, but an ant colony is incredible power, millions together. Don't underestimate small things. Small changes can create big effects. And finally, our relationship with nature. Humans think they control nature, but truth is, we're part of nature. If ants became giant, we'd become the inferior species. But this reminds us of something. Superiority is temporary. Today's most powerful can be tomorrow's weakest. Humility, respect for nature, cooperation with other beings. These aren't just moral values, survival strategies. Ants hold up a mirror to us. When we look at them, we see ourselves, social structures, hierarchies, cooperation, war, peace. Maybe we're not so different, just scale is different. And this thought is comforting and terrifying at the same time. Comforting because we're not alone. Universe is full of intelligence, full of complex life. Terrifying because we're not special, not unique, replaceable, but maybe this balance is necessary. Balance is pride, teaches humility, and tonight, while sleeping, maybe you'll think about the ants in your yard, those tiny creatures, silently working, never stopping. You'll look at them with respect, because you know that, under the right conditions, they could take over the world, and you'd just be a spectator. Good night, sweet dreams, and respects to the ants.